Whoa, that's super loud. This is the time right now. It's after midnight, and judging by my surroundings, you might have thought I stumbled upon some work site after hours. But what I'm about to reveal to you might shock and amaze you. I'm at the ZEEKR Intelligent Factory in Meishan, Zhejiang Province, and there's few lights on, even fewer people around. But right now, at this very moment, cars are being built and manufactured right here. It's a factory that quite literally never sleeps. And in case you don't believe me, take a closer look for yourself. This is what's known as a dark factory, a fully connected, automated production lines where machines work with near zero human intervention. And right now, you'll find engineering marvels like this mega die casting machine performing some of the most technically sophisticated tasks with perfect precision. All of this is only possible because of the extraordinary level of intelligence and connectivity embedded at every layer of the production line, what we call full-stack digitization. In this video, I'm going to tell you exactly why this new way of car making is so central to ZEEKR's competitive edge in the new era of mobility. But first, I'm going to do something that this factory almost never does: get some sleep. And in the morning, we're going to head over to the ZEEKR Intelligent Factory in Hangzhou Bay to see what makes that perhaps the smartest car factory on planet Earth. Welcome to the ZEEKR Intelligent Factory. This is what it looks like in the light of day. Over 300,000 cars are produced here every single year, including ZEEKR's most popular models like ZEEKR 001 and 009. It covers an area of 330 acres, which, to put it in perspective, is the size of about 250 football fields. ZEEKR, of course, makes pure electric cars, which puts ZEEKR at the forefront of the green mobility push. What this factory proves is that ZEEKR is also at the leading edge of smart green production too. This area of the factory site you see here is a massive solar farm that powers everything being made inside. There's 300,000 square meters of PV installation here, generating 40 megawatts of energy last year. The benefit of that clean power is equivalent to planting around 320,000 trees. But there's even more to the story than that. The factory runs on a fully connected Internet of Things infrastructure. That's exactly the dashboard in front of me I'm going to show you. This level of intelligence unlocks huge gains in energy efficiency. For instance, on the screen you can see at any moment how much solar power is available. This is of course dependent on factors like weather. What's more, it can make accurate forecasts about how much solar output will be available in the coming days. It also knows exactly how much energy will be required to run every process here. And armed with this knowledge, flexibly shift energy-intensive tasks like stamping and welding to times when solar power is more abundant. We can generate up to 30 to 40% energy savings and much higher energy productivity per vehicle produced. ZEEKR is green from the ground up. The cars themselves, of course, and the car-making process. To understand why this is such a game changer, you need to look at the dynamics of how cars were made starting from the beginning. The moving assembly line, launched in 1913, transformed cars from luxury playthings into mass-market essentials. It ushered in a new era of abundance, bringing prices down to a level where the middle class could afford cars. The reason this is so significant is because the previous model dominated automaking for decades and decades. That era traces all the way back to Henry Ford when the modern assembly line was invented.
Automotive manufacturing over the last 100 or 120 years has gone through several phases. The first innovation was back more than 100 years ago when Henry Ford started the assembly line process, and it was a flow process that improved efficiency and quality quite a bit. The second phase was lean manufacturing, which was an approach that was developed in the US but then applied extensively in Japan in the 1970s and 80s, and that improved productivity.
That model was updated and refined, but it endured for decades. So what were the key features for this era? Automakers would forecast demand based on historical sales data, economic indicators, dealer feedback, and market trends. Finalize build schedules, place orders with supplier networks, and pump out cars at volume. Car makers would then rely on dealer networks to sell and clear inventories. But the model was most successful under certain conditions. Products are planned far in advance. Normally, one factory producing no more than one model in huge volumes in a very standardized way. Meaning slower product development cycles and less opportunity for customization. It worked fine until it didn't. Cracks started to emerge. And the reason behind those cracks comes down to people. A new generation of digital natives grew up with smartphones, apps, streaming, and instant connectivity. Consumers wanted out of their cars the things they love most about other tech products in their lives, not having to settle for what's in stock at the dealer.
Consumers expect the vehicle intelligent features to evolve as quickly as they do their smartphone or their other electronic devices or internet-enabled devices. And so that's at a much faster pace than traditional mechanical vehicle development, which usually planned for a cycle time, a vehicle life of maybe 5 to 10 years. Now, consumers expect fresh models with updated technology every 2 years, and that requires a different mode of developing vehicles, where software development runs sort of in parallel to the mechanical development.
Bottom line, the moment was ripe for disruption, and a new class of automakers emerged, many coming from China and ready to match the needs of this new class of consumers. The ZEEKR Intelligent Factory is the apex predator in the new era of automaking. So what exactly makes this factory so innovative? First thing is we often think about factories in purely physical terms. Machines, hardware, equipment, the products that are produced, that is only half the story here. This factory is an ecosystem fully integrating software and hardware. The unsung hero here is the digital layer, which brings me to my first point. This place is designed to be much more intelligent. The best way to sum it up is full digital design, digital process simulation, and digital operations, everything connected by 5G.
AI and digital technologies are enabling factories that can be highly automated and reduce the amount of labor required to half or less of what it used to be, and improve the manufacturing costs and efficiency.
What I'm showing you now is one of the best examples of that. It's called digital twinning. What we're now looking at is a digital replica of the entire production floor. Engineers can test and validate in a virtual environment everything that takes place in the factory. This makes it possible to identify and spot potential hiccups before making real-world changes. You can roll out a new production setup quickly with a high degree of confidence everything will perform the way it should. The digital operation works much like a conductor in a large symphony orchestra. You have multiple instrumental sections like welding, assembly, logistics, etc., etc. The digital layer here brings order to all of this, making sure every section of the factory works in perfect symmetry. And to illustrate this, let's track the journey a car takes from the moment it is ordered to the finish line when it leaves the production line. Imagine I'm a customer. I place an order at a ZEEKR showroom. ZEEKR vehicles have pretty much countless customization options. ZEEKR 001 produced right here has more than 1.5 million combinations of options and some 20 options for wheels alone. This would overwhelm the factories of legacy automakers, which can only cope with a few small customizations like color options. Not the case here. So I pick out exactly what I want as the customer, and instantaneously the order data is sent here to the factory. Seamlessly, the system registers the components and materials that are required, and it is entered into the production schedule. So this area of the factory I'd call the central nervous system, and everything here is completely automated and controlled by advanced robotics. This area behind me is responsible for collecting all of the parts, and it's connected to the central scheduling system, which links directly to the order demand in real time, ensuring that all of the parts and materials always end up at their right destination in the production line, and we can handle the complexity over 1.5 million customizations here. So the room I'm in now and the screens appearing behind me speaks to the power of the digital control happening inside this factory. And one thing that's especially impressive is every single ZEEKR model has a digital record across its entire lifespan. So what that means is every single component installed, weld performed, or sensor calibrated, inspection passed is logged in real time. And if ever an issue arises, even many years after it's manufactured, all of that can be traced back to the exact station, machine, and shift it happened in. This factory utilizes the latest technology in stamping, but what's more, it's outfitted with high-resolution sensors that feed data into an AI system that analyzes key variables like force measurement, vibration detection, temperature monitoring, and precision of die alignment. It's a self-optimizing system. So let's move into the next stage of the production process, welding. So normally in a traditional plant, when you get to this area of the factory, it has a very distinct odor. It's very obvious, but not here. And one of the reasons for that is it employs a very different technique. Here, the process is 100% automated using 703 robots for the welding process. It's much more precise, much more high quality as well. I'll explain how. When it comes to welding, the optimal method is to apply a low current at the beginning to soften the materials being welded, then to gradually increase the current to melt them. The whole process only takes a second. Meaning, when done manually, you can only get so good of a result. These welding robots can divide that 1 second into millisecond intervals and create a dynamic current optimized at the millisecond level. Welding quality is massively important to product performance. ZEEKR 009 has 4,800 welding points on its frame. Each one is engineered to perfection. The robots use laser remote methods enhanced by AI systems to achieve an industry-leading 0.05 millimeters to 0.1 millimeters accuracy. Let's head over to the paint workshop to see this in practice. For a car to look and feel premium, the paint job has to be sublime and absolutely perfect. In order to achieve the highest possible standard, each and every step of the paint process, from pre-treatment to primer, main coat, and clear coat, involves a comprehensive vision AI scan. First, high-resolution cameras and sensors to detect any defects down to the micron level. Cameras are AI trained on massive datasets to detect variations in shade or reflectivity invisible to the human eye. There's one more area of the factory I want to show you, and trust me, I've saved the best for last. So ZEEKR established the world's first large-scale integrated die casting L4 production line. That's this beast you see right here behind me. Is 100% automated, and it weighs, wait for it, 7,200 tons. So mega casting technology is super useful for creating large structural components like the rear frame of certain models. And why it's really important is because there's fewer pieces stamped together, which delivers much more structural integrity and better safety. Fewer welding points, much more structural integrity. And it's used in models like ZEEKR 009. For 009, the bending stiffness of the body is 11% higher. Torsion rigidity of the body is 36,450, 3 times as high as that of a traditional NPV. Torsion rigidity of a vehicle is a key attribute by which we can tell how much deformation in a crash the vehicle in question can withstand. It's a key reason 009 is nicknamed the road tank. That's it for this episode of Behind the Z. I hope you've all learned more about why the ZEEKR Intelligent Factory is so critical to our business model and also bringing the most innovative products to you, the user. Take care, guys.
Für mehr Videos einfach abonnieren.